Okay, we are going to finish up rectangles in your foldable. So go ahead and take that out. You can pause it when you need to pause it. But we are going to add some color and get our definitions in there so that we are finished up with this one. So we have definition of a rectangle. Our definition of a rectangle is a quadrilateral with opposite sides congruent and 4 right angles. So we have opposite sides congruent and we have 4 right angles. So let's go ahead and mark up what we've got there. So we have this side congruent to this side. This side congruent to this side, and then we have 4 right angles. So let's talk about the different things that we know. We know that opposite sides are congruent. Let's use this a little darker. We know the opposite sides are congruent. We also know that opposite sides are parallel. Need to add that in there. And opposite sides parallel. So let's go ahead and put our little arrows. That shows those 2 sides are parallel. And these 2 sides are both congruent and parallel. Okay. Opposite angles. Well, opposite angles, they both are right angles, so they would be congruent. Consecutive angles, well, that means in a row. So right angle, right angle. So consecutive angles would be congruent, but they're also supplementary. Now, the proof that you had last night was diagonals. We found out that our diagonals are congruent to one another. And we have 4 right angles. Forgot to mark my diagonals up here. Let's go ahead and mark this diagonal congruent to this diagonal. And we also know that diagonals, oh, I messed that up, my bad. This should say diagonals bisect. Let's try that again. Bisect each other, and diagonals are congruent. So diagonals bisect, so we're going to use, I'm running out of colors here. I've already used my 2, so let's do 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So that shows that they bisect one another. Now you're going to use these properties. You can go ahead and finish out your example 1, example 2, and example 3 to do those. That's part of your rectangle assignment. Let's also take a look at one of those proofs that you had last night. Let's take a look at the proof number 4, I believe it was. Yeah, number 4. Let's do that one so that you can kind of check yourself and see how we did with that. And that will finish up our rectangles here. So let's start with, we have rectangle. This is number 4 on page 6. So we have our rectangle. It is L, M, N, O. And we have our diagonals. And there's K. So they told us to prove that the diagonals bisect one another in number 4 is what we're after. We want to show that LK is congruent to KN and so on. So the picture that we drew yesterday, the coloring that we did yesterday, was we wanted to show this blue triangle to be congruent to this green triangle. So we are going to start our proof with what is given, and that would be rectangle LMNO with diagonals LN and MO, and that would be given. That would be step one. Step two, well, we've got in that proof, I'm seeing some vertical angles there. We're trying to show these two congruent. Well, then I most certainly know that angle MKL would be congruent to angle OKLN, and those two would be vertical angles, so there is an angle. I also know that LM is congruent to ON. Reason would be definition of a square, or not a square, my bad, a rectangle. So I've got those two sides. I also know that LM is parallel to ON, and that would be property or a definition of rectangle. Well, if that's the case, then I can pick up an alternate interior angle, because these two would be parallel, and I have a transversal, so I know angle LMK or LNO is congruent to angle, I did LMO, so this guy would be congruent to NOM, angle NOM, and that would be from alternate interior. So I can finally say that my triangles are congruent. So triangle LMO is congruent to triangle NOM. I will LMK is congruent to NOK, and we have angle, side. Then if you know that that is true, so I've got triangles congruent, well then I know the sides have to be congruent because of CP, CTC. So LK has to be congruent to NK, and OK has to be congruent to MK. Those are both CP, CTC. So this shows that the diagonals bisect each other. So that's to help you out with proof. This was number 4 on page 6. So that shows you that part. So your assignment for rectangles, we started it last time. You're going to finish out the foldable. You're going to do example 1, 2, and 3. And then you already did the 2 proofs. On page 6, you are going to do 5, 6, 7, 8, and 9 on page 6. Now these aren't difficult. They're just asking you to name a property that you would use in this particular word problem. You're not actually solving the word problem so much as just telling what property you would use and what you would do that. So that finishes out rectangles and what we're going to do with them.